Right, welcome to tonight's lesson. So this lesson is lecture 2, and it's just a continuation of where we ended yesterday. So we're still doing conic sections, which is sometimes known as analytical geometry. So tonight we're going to focus on the ellipse. So yesterday we discussed the circle. We also looked at the straight line. So tonight our main focus is going to be the ellipse. Then if we have enough time, we'll also start the parabola. Yeah, so that at least we just remain with one meeting to finish analytical geometry. Yeah, it's not a long topic, like I said when we just began. It's not a very long topic, meaning we're not going to take a lot of time discussing this. Okay, so let us quickly begin. So those that have not yet made the payments, these are some of the numbers that you can use to contact me on Telegram and on WhatsApp. These are the contacts that I use. And then if you want to make payments, you can use any of these bank accounts. You can use mobile money, which is MTN or Airtel. You can use Zapid. You can use Zanaco and FNB there. Yeah, like I always say, if you're outside Zambia, you should just contact me. There's the simplest way of sending money across countries. All right, so like I said, it's only 100 kwacha per course every month. Yeah, so let's begin to discuss tonight's lesson. So we are going to look at the ellipse. Let me just change the color of the marker. So we're going to begin looking at the ellipse tonight. So I don't know, maybe some of you are hearing about this name, this word for the first time. So when you talk about the ellipse is more like the circle, but it's not really a circle. It has an egg shape, in short. Let me just say it that way to understand. It looks like this. I'm sure you've seen something that looks like this. Yeah, so this is an ellipse. So you can have an ellipse which is directed along the y-axis. Then you can also have an ellipse which is directed along the x-axis, meaning it will look like that. Yeah, so yesterday we discussed the general formula of a straight line, which was y is equal to mx plus c. We also looked at the general formula of a circle, which was x minus h squared plus y minus k squared is equal to r squared. So tonight we're going to look at the general formula of an ellipse. So the general formula of an ellipse is not just one. For the circle, you just have one. For the straight line, you have one. But for the ellipse, you have two, because you have one which describes an ellipse, which is parallel to the y-axis. And then there's also another equation which describes an ellipse which is parallel to the x-axis. All right, so let's quickly look at these equations. So the first equation is this one. So as you can see, like I said, an ellipse is more like a circle. That's why you are seeing some of the components that were in the equation of the circle, the general formula of the circle, are also present in the ellipse. So you can see this is the equation of an ellipse. Yeah, but I'm going to tell you whether it's in the x or in the y. And I'm going to tell you how to know whether the given equation is in the x, describes an ellipse which is in the x or in the y. All right, so the center of this ellipse is found in the same way that we were finding for the circle. So you have to equate whatever that is in the brackets there to 0. So if for instance, you have this as your equation, you have to say x minus h is equal to 0. you also say x minus k is also equal to 0. So once you find the value, sorry, this one is supposed to be y. So the center of this is therefore going to be h, comma. When this crosses the equal sign, you get k there. So I mean the center of this ellipse is going to be h, comma k. Yeah, so when describing an ellipse, you are supposed to find Hari Lungu. Check your phone properly. You are writing on the screen. Okay. If you can manage to delete, please just erase what you've just written. Okay. So this is the center of the ellipse. And if you've been asked to describe the ellipse, the first thing that you need to do is to find the center. And then after finding the center, you have to find the length of the major axis, the minor axis. You know, we're going to discuss that and you understand them better when I show you the sketches of, or how to sketch the ellipse. All right, so this is the general formula of an ellipse, which is in the x-axis. Then you also have the other formula of an ellipse, which is in the y-axis. So what determines whether the ellipse is directed along the x or the y-axis is the value of a. So when the value of a is under the x coordinate, like in this case, when a is under the x coordinate, you consider that ellipse to be parallel to the x-axis. So meaning for this one, you have something which looks like this. Then when you have the value of a, under the y coordinate, you expect the ellipse to be parallel to the y-axis like that. That's how you know. So now, how do you know? Because these values are not going to be in symbols like this. These are going to be numbers, meaning the equations will be like, you have something like this: x minus 1 squared plus y minus or plus 2 squared, and then everything divided by, sorry. Yeah, so you have over, maybe you have 9 there, and then you have 25 there. Then always, when you're dealing with an ellipse, this side is always supposed to be 1. So if you've been told to derive the equation of an ellipse, should always make sure that on your right here, you have 1. And that's one thing that will help you to know whether this is an ellipse or not. Yeah, so same applies to the hyperbola. The equation of the hyperbola also looks the same as this, but here, instead of having a plus here, you're going to have a minus. That's the only difference. And the sketches are also different. But the other things that you find when describing are all the same. All right, so let's quickly continue. So I was talking about how you can identify whether it's in the x or in the y. So I told you to say when the value of a is under the x coordinate, it means that it's in the x, it's parallel to the x-axis, like that. And then when the value of a is under the y coordinate, it means that it's parallel to the y-axis, like that. So this is what it means. And then apart from that, you also need to know how to identify a, because you might be given an equation, or you always be finding equations which in this format, the values of a and b are numbers, but how do you know that this is a, or how can you tell, for instance, this equation that it's either in the x or y? How can you know? So what you need to understand is that always for the ellipse, the value of a is greater than b. So when you look at these two numbers, the biggest value is the one that you take as your a. And what is this a and what is this b? So a is just the distance from the center of the ellipse to the vertex, to the vertices, yeah. from the center of the ellipse to the vertices. So from the center there up to that point, this distance from there to there, that's the one that we call A. Then from that point to that point, we call this distance as A. And then the distance from the center to the minor vertex, or to the minor vertices there, from there to there is B. Even there we have B. And then apart from knowing how to find all these, you also need to know how to find the focus. So the focus of the focus of this ellipse is always between A and the vertex. And how do you find the focus? If, for instance, it's somewhere there, how do you find the focus? So the focus, how do you find the focus? So to find the focus, we need to find another number, which is denoted by C. So C squared is given by A squared minus B squared. I think I've said a lot of things. Let me try to maybe put up the diagrams which are clear. Okay. So I said the center is H comma K. And for this equation here, this is the diagram. Like I said, if the value of A is under the X coordinate, you expect your ellipse to be directed parallel to the X axis. And always know that the value of A squared is greater than the value of B squared for the ellipse. Yes, for the ellipse, the value of A is always greater than the value of B. Then that is the equation that describes the ellipse, which is in the which is directed along the y-axis. And this is because the value of A is under the y coordinate there. So this is what I was just explaining. And then the other thing that you need to find when you've been taught to describe an ellipse is the distance from, let me change the color of the marker. So you need to find the distance from that point to that point. And this is known as the length of the major axis. So how do you find the length of the major axis? Remember what I told you. I told you that the distance from one vertex to the center there is known as what? A. It's the one that we get as the value of A. So meaning to find the distance from this point up to that point, meaning you have two A's there, meaning you're going to add this A and that A, which gives you 2A. So the distance from this point to that point, which is the length of the major axis. So the length of the major axis is given by 2A, is found by multiplying 2 by the value of A. And then the length of the minor axis is therefore, or is also going to be found in the similar way, because we know to say the distance from the center to the minor vertex there is equal to B. So the length from this point to that point is simply just given by what? 2B. So the length of the minor axis is given by 2B. And then there's also another thing which is it's supposed to find, and this is known as the eccentricity. So the eccentricity is given by C over A. So this just describes, okay, this is just a ratio which describes how, I don't know how I can say it, but how this ellipse is, okay, we all know to say this is a circle. An ellipse is just a circle which you just shrink. Maybe if you shrink this circle from these from these sides, you shrink the circle, it will form an ellipse, it will form something which will be like this. Yeah. So now it's just a ratio of how this is close to its original circle. Yeah, but for better understanding, maybe you can try to Google it. Yeah, so that is the eccentricity. It's a ratio. That's the reason why we're saying C over what? Over A. Okay. So these are some of the things that you are supposed to find when you've been asked to describe an ellipse. So you find the length of the major axis, which is equal to 2A, the length of the minor axis, which is equal to 2B, and you also find the eccentricity. Yeah, so I told you to say C is found by subtracting B squared from A squared. All right, so let's quickly look at some of the examples. Okay, let's look at these two examples. So the question is find the vertices and the foci of the ellipse given by the equations below. So sometimes they will not tell you to say this is an ellipse. They'll just say describe the following conic sections or describe the following geometries. And you have to determine whether it's an ellipse or it's a circle or it's the parabola or hyperbola. So now how do you know that? You look at the equation. So that's why I told you to say you have to be good at mastering equations for this topic. Okay, let's quickly begin to discuss. All right, so how do you discuss these conic sections? So the first thing, I'll start with this one here. So the first thing that you need to find, because this is, we already know to say this is an ellipse because we've been taught from the question. And the other way you can tell that this is an ellipse is to check the sign in between there and the format, and also to ensure that you have one this side. You have to first check the sign, ensure that this is a plus. If there's a plus here, if there's a plus here and you have one this side, you have to know to say what you have been given is what is an ellipse. So now, if this ellipse has both the values of A and B equal to 1, it becomes a circle. That's why I told you to say an ellipse is just a shrinked circle. Yeah. All right, so let's continue. So how do you describe this? So remember the equation of an ellipse, the general formula is x minus h squared over, so this can either be A or B squared, then you say plus y minus k squared over, this can also either be A or B. And then this side, you are always supposed to have 1. So this is the general formula of an ellipse. So now when you check what you have been given there, you know to say, if you want to find the center of this ellipse, you have to equate whatever that is in the brackets there to 0. So in other words, there in the brackets there, we only have x. So when you equate x to 0, this gives you the value of x to be 0. When you equate y to 0, it gives you the value of y to be 0. Hence, the center of this ellipse is 0, 0. And the other thing that you need to find when describing the ellipse is to find the value of A, B, and C. So to find the value of A, remember what I told you, when you're dealing with an ellipse, A squared is always greater than what? B squared. A squared is always greater than B squared. So the biggest number between the two numbers that we have there, between 25 and 49, is the one that we get as A. So in this case, our A squared is equal to 49 because 49 is greater than what? 25. So our A squared is 49, meaning the remaining number, which is 25, is equal to what? B squared. So to find the value of A, you just need to square root both sides. So when you find the square root of 49, you get 7. When you find the square root of 25, you get your B as 5. All right. So after finding this, you can now find C. So to find C, C is given by, C squared is given by A squared minus B squared. So to find the value of C, we say C is equal to, our A squared is 49, our B squared is 25. So you have to subtract 49 minus 25. And when you subtract 25 from 49, let me just demarcate here. So when you subtract 49, rather 25 from 49, you get 24. So you get 24 this here. So C is simply just equal to the square root of what? 24. So C is equal to the square root of 24. Okay. So after finding C, we can now sketch the ellipse. Yeah, so whatever that we have forgotten here, we'll be finding as well sketching. Then since we've been told to discuss, you are also I mean, this question is just asking us to find the vertices and the foci, and also sketching, though it has not asked us to sketch. So just finding the vertices and the foci. Okay, but I'm also going to sketch for proper understanding. And then after sketching, you also find the length of the minor and the major axis. All right, so let's quickly do the sketching. So now let's check, is A under Y or X? So when you check the biggest number between 25 and 49 is 49, and it's under Y. And this tells us to say this given conic section is directed along the Y-axis. So we expect it to be like this. So let's do the sketching. So this is our center. Our center is 0, 0. So we expect our center to be somewhere there. Then we have our x-axis, y-axis. And then we can now draw the conic section. So now how do you sketch? So we know to say A is simply the longest distance from the center to the vertex. So A is greater than B. So we move 7 steps from the center, going up and down, because we know to say it's directed parallel to the y-axis. So we move 7 steps going up. 1, 2, 3, 4, 5, 6, 7. So we have 1 point there. 1, 2, 3, 4, 5, 6, 7. We have -7 there. Then we move 5 steps along the x on both sides of the center. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So sketching this, it's going to look like this. Okay. So this is how it's going to come out. So after doing this, we can also find the length of the minor and the length of the major axis. All right, so the length of the major axis is given by 2a. So this is major axis. You can finish writing that. 2a. So 2 times the value of a is 7. So put 7 there, and this gives you what? 14. Then the length of the minor axis is given by 2b, which is 2 times the value of b is 5. So this gives us 10. So here, I don't know if I've forgotten anything, the eccentricity. Okay, so eccentricity is simply given by C over A. So eccentricity is equal to, the value of C is the root of 24 over A. So the value of A in this case is 7. So we put 7 there. Okay, so this is the eccentricity. So now we have not answered the question. The question is asking us to find the vertices and the foci. So what the question is asking us to find are these points. We have this point, that point, We have that point, we also have that other point. Of course, these are simple points. You can easily locate them even just by looking at the diagram. That's why I prefer sketching before you start writing the points. It helps like that. So if you just want to start guessing the points, or you want to start stressing yourself by thinking of what these points are going to be, you're going to waste time. You're going to spend a lot of time just trying to figure out the points. Okay, so this coordinate here is, so I'll call this my V1. So V1 is 0, 7. Then we have V2. So V2 is 0, -7. Then I'm going to call this M1. This is my minor vertices. So M1 is 5, 0, and M2 is so M2 is -5, 0. So these are the vertices. Now we have to find the foci. So we have the first focus should be between the center and this point, and the second focus should be between the center and this other vertex, between the center and V2. All right, so now how do you find those? So since it's in the Y, remember the formulas that I showed that I showed you on the previous page. I don't know if you saw them. Let me just show you for the sake of revision. I mean, for the sake of understanding. Let me change the color. So if you are finding the first focus, F1, if it's in the Y, we know to say the value of X is constant, and what changes is Y, is the value of Y. So you simply just have to add Y to C to find F1, and then you subtract C from the Y coordinate to find F2. So what I mean is, to find F1, you are going to add, we know to say in the Y-axis, the X coordinate does not change. So to find the first focus, which is F1, let me write it here. So F1 is going to be, the value of X doesn't change, so we still have 0 there. Then we say comma, and then the Y coordinate is also 0 in the center, because the center is 0, 0. So to the Y coordinate, we're going to add the value of C. So when you add the value of C, this is going to be the root of 24. So 0 plus the root of 24 will give us the root of 24. That is F1. Then F2 will do the same, because we know that in the Y, the value of X does not change. Then to the Y, from the Y, we're going to subtract the value of C to find F2. So the value of C is root of 24. So root of 24. So we're going to say 0 minus the root of 24, which will give us negative root 24. So our F1, when you find the square root of 24, this is close to 5. So we expect these points to be somewhere. Okay, this is 1, 2, 3, 4, 5. So we expect these the first focus, which is F1, to be somewhere there. So F1 will be somewhere there, which will be 0, the root of 24. And then F2 be somewhere down here, 1, 2, 3, 4, 5. So to be somewhere there, which will be, so this is our F2, which will be 0, negative root 24. So these are the focus, that you are supposed to find. All right, so let's quickly move on to the next. Or before we move on to this second part of the question, do we have any questions here before I proceed? Do we have any questions? Okay. So it seems like people are understanding. All right, so, okay, there's a question, let me check. Please repeat on how you find the focus. So finding the focus, you just need to add and subtract the value of C from the y coordinate if the ellipse is directed along the y, and if it's directed along the x, you have to add and subtract the value of C from the x coordinate in the center. That's how you find the focus. So let me repeat this. So to find the focus, you need, to find the focus, you need to find, you need to add the value of C to the y coordinate of the center if it's in the y-axis, if it's like this. And then if it's in the x-axis, to find the focus, you need to add and subtract the value of C in the y-axis, from the x coordinate of the center. That's what I did. So in this case, the the y coordinate of the center was 0. That's the reason why even after adding 0 and the root of 24, I still got the root of 24. Then after subtracting the root of 24 from 0, I got the negative root of 24. This is what I have there. I hope you've understood. Okay, so looking at the time there, the Zoom link is showing us that we're remaining with 3 minutes. So I'm going to cut the meeting right now. I'm going to end the meeting. Then we should join using the same link after 3 minutes. So let's join using the same link after 3 minutes so that we finish up with the remaining part of the slide.